on QuickTime Player. But we don't have to change. We don't have to be like, we can still be ourselves. No curse words. Not that you curse. All right. There are 24 questions on here, but only 12 on the final. So each question on the final corresponds to 2 questions on here. Sid, go back to the row. Sid, we're not working in group script. Go back to the row. Really tough. Okay, so the first 3, they might not necessarily be in this order on the test, so you'll have to be able to pick them out. You'll have to be able to figure out what type of problem it is. But the first 3 on here, the first 6 on here are momentum problems. So it's kind of older stuff, but you guys did real well with it. Which of these letters is momentum? Nope. P. This is momentum. It's measured in kilograms, meters per second. Another equation that we'll use is the change in momentum. So that's m v final minus v initial. So delta, what does delta mean? Change. We learned something this year. In total is the last equation I'm going to write up here. These are all provided for you. These and more. But these are the, I don't know why I put the initial there. It's not necessarily initial. When you're calculating total momentum, there's going to be 2 carts. So you take mass of cart 1 times velocity of cart 1 plus mass of cart 2 times velocity of cart 2. So that's our total. This guy, sigma, stands for total. And those are the 3 main ones, but I have a handful of other ones written on there, on the actual test. Hmm?
So,
Yeah.
this equation sheet that came with the study guide, well, not came with it, but the one that's on Moodle,
Oh, okay.
you want to, is that the same we'll have on test?
Yes.
Okay.
In fact, when you said that, I thought I accidentally gave out the test just now
Oh, no.
because I didn't hand out the equations with the study guide. So yeah, if you want to use the equation sheet, you can look at Moodle. You can print it out like Michaela did, same one. I forgot 2 equations on there, but we'll see those on Monday anyway. Okay, so with 1 through 6, you're kind of just picking information out of the paragraph, and they're all going to have the same picture. So there's 3 on the test that look like this. They'll have 2 carts moving towards one another, and then they collide and they move in opposite directions. So this picture will be the only picture you're looking at when it comes to momentum. It's the details that differ. For example, as it says, this one's 2 kilograms. I feel like we should read it. A 2 kilogram cart is moving right with a velocity of 6 meters per second, and a 3 kilogram cart is moving left with a velocity of 3 meters per second. So let's put those in there. 2 kilogram cart moving right with a velocity of 6 meters per second. 3 kilogram cart moving left with a velocity of 3 meters per second. Technically, we're not supposed to, well, forget about technically. Let's do what's right. That's a -3. Super important in momentum problems, not very important in future problems. After the collision, the 2 kilogram cart moves left with a velocity of 4.8. So that'll be this one. On the bottom left, it's going left with 4.8 meters per second. Throw our negative sign on there. Even though they didn't say it's negative, they said left. It's all the same. And I actually didn't read on, but I know that one's 3 kilograms. Left with a velocity of 4.8. 3 kilogram cart moves right with a velocity of 4.2. Put that in there. Calculate total momentum before and after. So what would I do what math would I do to get the momentum of just this cart right here? Bless you. Multiply what by what? 2 times 6 would get the momentum of that one. 3 times -3 would get the momentum of that one. So that's the total momentum of the system before they collide. So that equation that we have up here is a little more versatile than it seems as it's written. We can put initial, initial, initial. We can also put final, final, final. And it's written in both forms on the equation sheet, I think. And that's what we'll do here. So total momentum before, I'm going to put a little 0 or a, I don't even, I don't know if that's a 0 or an O. I think it's a 0. But anyway, see, I've been writing it for 5 years and I don't even know. It doesn't matter. We know what it means. Initial. So 2 times 6 plus 3 times -3. I can't do that in my head. I think it's 3. Oh yeah. 12 minus 9. Very good. 10 points for Gryffindor. I mean, I just like Gryffindor, so I'm giving points to him. I'm not even a Gryffindor, technically, if we're going by the Pottermore rules. So this problem asks us to calculate total initial momentum. They ask us to calculate final total momentum. They didn't phrase it like that, but that's what they mean. Calculate total before and after. So here, we'll take the same 4 numbers. If you draw the picture, it's really easy to solve. You just multiply those and add them to those 2 multiplied. So that means 2 times -4.8 plus 3 times 4.2. Does anyone know what the answer is before typing in their calculator? Should be trace. Momentum is conserved. The total momentum is the same before and after the collision. And this is true for our entire universe. The total momentum of the universe is the same tomorrow as it is today. Pretty serious stuff. So when you're doing this problem on the test, if they say calculate total momentum before and after, you should know that they have the same number as their answer. They should be the same sign and the same number. Same units, of course, too. The difference is the next problem. The next problem, it's the same numbers. I don't know, it's different numbers, but it's like the same picture. If we're calculating change in momentum, like the change in this cart and the change in this cart, those 2 changes will have equal and opposite numbers. For example, if this was 3 as a change, this would be -3 as a change. But total, same number. Let's do that. 3. We see that there's a problem about carts. We know that's the same picture. Yeah, now we should read the problem. Okay, a 2-kilogram cart is moving right with a velocity of 2, and a 3-kilogram cart is moving left with a velocity of 6. So that's 2, 2, 3, 6. 2, 2. They're going right. I think it was 3 kilograms and 6 meters per second. Mr. McGuire, where'd that negative sign come from? Going left, so it's negative. Very good. Next sentence. After the collision, the 2-kilogram cart moves left with a velocity of 7.6, and the 3-kilogram cart moves right with a velocity of 0.4. So 7.6 and 0.4. Ooh, These mixed up. Oh, that was good. Okay. See if you can catch the mistake. That's right. That guy's supposed to be negative. This guy. Negative 7.6. Now the difference this time is what they're asking. Same type of problem, but you have to read very carefully. I remember on the test for this chapter, a lot of people were calculating the wrong thing. It says calculate the change in momentum of each cart. And that is this equation. It's the best one to use because we have both velocities, before and after, and we have the mass of each cart. So I think this one might be a little easier. Kind of opinion. I have a blast picking the colors. It's a lot of excitement for me. Okay. 2 times, well, we're going to subtract, so it's something minus something. Which one goes first? Final, the 7.6. Super important here. Okay, so here's what we're writing. Delta P equals 2 times negative 7.6 minus 2. Kind of skipped over the parentheses, but that's okay. $19.2? Okay. Negative 19.2. That's what I got too. Negative 19.2 kilograms per meters per second. What's the change in the other cart? We know without doing any math.
19.2.
Positive 19.2. So if you know that, you can just write equal and opposite plus 19.2. You can't just write the straight up answer because I don't know if you copied off your neighbor. You have to do some sort of proofs. You can write equal and opposite, and I know what you mean, or you can just show the math. It's not too much. I forget the numbers. Cool. Yeah, that's weird. That's about it. Easy peasy. How are we feeling? Are we scared? Math is scary. Time to be. It's been time to go home for a month.
You're so right.
I know. I'm not gonna lie to you.
You could have never came here, August. I would have been okay.
I mean, come on. How much has really gotten done after the seniors left?
Nothing.
How much got done before this year's left? I don't think we need to be here right now.
Fair enough. I feel like we should be on a more college type schedule,
I agree.
but you know.
Yeah, whenever we want, so never.
Alright, class optional. Unless you-
We're here.
Am I? Oh.
Are we? What? Whoa.
Interesting.
I'm learning.
Interesting.
Look, see, look,
Okay.
you know what has been accomplished since the beginning of the year?
What?
You learn how to work the
That's true.
smartboard.
It's exciting. It's kind of fun. Figuring her out. I keep jumping the gun. Okay, so number 5. I'm so bored of these problems because they're all the same. Cart 1 has a mass of 5 and moves right with a speed of 4. How exciting. Cart 2 has a mass of 3 and moves left with a speed of 6. Okay, so mass of 5, moving right at 4. Mass of 3, moving left at 6. 5 kilograms, 4 meters per second. Forgot already. 4 kilograms?
3 and 6.
Dang. 6 meters per second left. That's another one that I messed up on the. Oh, I'm looking at the wrong problem. Cool, we're all good. So on this one, the difference in this problem is that I think it's written in there, is it? No, it is not actually written in there. So here we're not trying to find total and we're not trying to find change. We're asked to find something specific. So we have this outcome that we don't know much about. I think we have one of their velocities.
5.
It is. I think that's what we're looking for. Or maybe the mass. Wait, no. Okay, and then we know this is 2. Cool. Okay, so this is the third type of momentum problem, where you actually have to find a specific variable, like mass, velocity. Actually, that's pretty much it. Your mass of one of the carts or your final velocity of one of the carts. And with this, we have to use the conservation of momentum. A little scarier, but it links to what we saw here. I'll come back to that if you missed it. Okay, once again, what's true about our total momentums? They're the same. Before and after, they are the same. So we can use the conservation of momentum. M1 V1 initial plus M2 V2 initial. This set of terms represents our total momentum before the collision. The momentum of both carts before the collision. That's going to be equal to M1 V1 final plus M2 V2 final. That's this right-hand side is the total momentum after the collision. It's a scary equation, but it really is only 2 variables. It's mass and velocity at different points in time. So we kind of just throw these numbers on the left, and these numbers get thrown down on the right. Let's see what we can do. 5 times 4 plus 3 times -6. 5 times 4 plus 3 times -6 equals 5 times -2 plus 3 right, yeah, we just leave it. Final velocity of 2. I like this problem because it looks frightening at first, but when you actually compute it in your calculator, it gets wicked simple. Or maybe you can do that in your head. 20, 18, 5 times 2.
Boy.
Oh my gosh, we might not need a calculator here. Add 10 on both sides. 10 plus 2. 12. Oh my gosh.
Look at that. And it's positive.
Yeah,
It is positive, just like our attitudes.
yeah, totally. You're totally right.
I used to say that all the time. I'd be like, we have a test tomorrow, so bring your pencil, your calculator, and your positive attitude. People didn't like that.
I'm bringing Yeah.
Are we going too fast?
No.
So the evens 2, 4, and 6, those will be good practice. They're a lot like the 2 we just saw. And there's 3 like that on the test. So the next section we're going to talk about is energy. And then we'll call it a day here. So we'll do 7, 9, and 11. And then you can work on the evens, or you can meditate, use your coloring book, whatever you got to do.
Yo, I should get a coloring book.
Coloring books are awesome.
bad. So my last month of school feeding, yeah, I'm bringing color. All over my
You should bring one. You should bring one every day.
Like some people-
Do it at lunch when you're not doing anything.
Well, no,
It's
I
relaxing.
don't. That's my actual.
What about
That's small.
what it's called home birth network?
Okay. I think there's two things. Now let's just dive in. Let's just do it. Okay, here we go. Number 7. A 12-kilogram hammer is dropped from a height of 2. Use the conservation of energy to calculate the velocity of the hammer as it hits the ground. There's something important in there. What are we supposed to use?
Hammer.
Conservation of energy. The test will say that. So these energy problems, they probably won't be bunched together. They might be peppered in throughout the test. But when you see that, use the conservation of energy, it means use that scary equation that scared you at first, but wasn't really that bad. I mean, that's just my attitude about it. This is the conservation of energy. And it's on your equation sheet, so you don't have to memorize it. You just have to be able to pick it out of a lineup. There's our conservation of energy. We're almost always going to cancel out the m's. We'll see one where we don't. Let's do that now. Let's cancel out the m's. Because if we divide m on both sides, it goes away.
Oh, I have to go home.
No. Only 3 more. 3 more hours. Oh my god. 3.5. Wait.
It's just the velocity split, right?
2.5. Okay. What about the velocity? Yes, the velocity. Yeah, just the velocity. Yeah, wait. What's VO?
Initial.
Finish. Yeah, I don't know why I'm trying to trick you. You guys know that. Oh, what about HF?
High school.
Final height.
High school.
It's high school. Let's see what else we can do here. Well, okay, so a hammer is dropped from a height of 2. What about that 2? Where's that 2 gonna go? HO, all right. When it hits the ground, we want to find the velocity as it hits the ground, so I'm going to put a question mark above that, just so we know what we're trying to find. And I'm kind of stalling because I'm hoping someone will figure out what I want to do next.
Take
But
it. That's
is there something that we can plug in that they didn't tell us? HF is 0, that's one of the things. HF is 0 because it hits the ground. G is 9, it'll be just positive 9.8, but yes.
Why?
G is always positive 9.8. Sometimes we have equations where we use A is negative 9.8, but if it's written as G, then it's positive. There's another 0 though. VO. Why? It's dropped. The initial is 0 because it's dropped. So this equation cleans up real nice. Here's what we have left. GHO equals 1/2 BF squared. Beautiful. Nine 9.8 times 2 equals 1/2 BF squared. We'll multiply both sides by 2 because that'll cancel out the 1/2. That'll leave us with 39.2, I think.
Yeah.
Equals VF squared. Square root it. When you square root it, don't forget that little step you're supposed to take, plus or minus. This is the only problem where it's important, but you should check on it every time. Why am I going to go with negative here? It's dropping, it's falling. And that's why we have to do plus or minus. It could be something that was, well, yeah, that's just weird. I'm so tired.
Yeah, we should've did this before we started watching the movie, I ain't gonna lie.
Yeah.
But then you'd watch the movie and forget everything.
That's the point.
We should've just not.
We should
Not
just
watch
stop
the movie. The movie was amazing.
We should have
It's
just watched the
amazing.
movie.
And Mr. McGuire got a lot of grading done.
Ah,
I feel like we're done here on this one. Yeah. I'll go back if you want to. Okay. Now that objective, it's conservation of energy with a couple of zeros. That means some stuff's going to cancel. Number 9 has few cancellations. We'll still be able to cancel out mass, but there's not going to be any zero values that chop the equation up. So let's see what we have. Let's figure out what's initial, what's final. A 1,400 kilogram coaster is moving with a velocity of 5.7 meters per second. When it is at point 140, that's kind of weird. Let's look at the picture. What is 140 in that picture representing? Initial height. Very good. So if that's the case, let's see if they gave us final height. What will be the car's velocity at point B? There it is. Final height is 95. So, okay, we have initial height, we have final height. What are we trying to find then? VF. That means that 5.7 is VO. So that's a lot of info. Maybe you don't need to write it down, but I'm gonna. So V initial is 5.7, H initial is 140, and this should be like, I'm just scribbling stuff. V final is question mark, and H final is 95. Okay. That's all the physics in this problem. That's it. We're done with all the physics. Now we're just doing math. We're just plugging it into the equation and solving. So I'm not going to write out the full conservation of energy equation. I think it'll burn a lot of our time. But we are going to cancel out m's. So it is the conservation of energy equation. The m's are gone though. So instead of mgh, it says g times h plus 1/2 times 5.7 squared. Again, the m is gone. Equals 9.8 times 95 plus 1/2 times the final squared. And 8 is crazy as it might seem. The left-hand side can just be typed in your calculator and it'll spit out a number at you politely. Yeah, I think spitting is rude in general. You're right. You're right. 1388. You got an answer already?
No.
Oh, okay. Gotcha. Ooh. We're good. Okay. So 1/2 the final squared. I think you know what to do from here. Subtract 931. Then we'll multiply both sides by 2. And then we'll square root our answer. When we square root, we need a plus or a minus. So I'm going to skip to that last step, square root. EF, at that point we'll have 914. So square root both sides, do a plus or minus. On this one, we might not agree, but let's see. Okay. So what direction do you think What direction do you think it's going in the picture? At 95, like it's going like
So,
it's kind of like, so is it going straight up, straight down, straight left, straight right, or is it like a diagonal? It's kind of weird. So the technically, well, yeah, technically every part of the coaster is going to be going in a different direction. Like when you get to the top, like the front cart is moving right, but the other carts are still moving up. So this is one that's kind of inconclusive. I don't really mind what you put there. I would put nothing because we're probably going to need to look at an angle if we want it, if we want a direction. But mainly for problems like this, where something's going sideways, or problems like this where something's going, wait, this is not the one. The one where we dropped it, wherever that was. If it's going sideways or vertical, that's when we care about plus or minus. But on an angle, we're not really testing that this semester. That was first semester, which, not fun.
no.
All right, last one.
And so,
Till Monday. Woo!
if I come back.
I think Monday will be easier because this is all the old stuff that we're doing right now. All right, here we go. 47-gram golf ball. Stop right there. 47 grams. Get out of here. We want to divide that by 1,000. 0.047. Hey, Michaela, do you have that equation sheet there?
Yep.
Is there a conversion for kilograms to grams on there? Is it on there?
Yeah.
It's probably on the test.
I mean, I need to look that up, but
Yeah, there's a total of 2 surprise unit conversions on the test. I'm kind of jumping the gun here. I didn't even read the rest of the problem, but that's okay. I just spoiled something.
So I'll be taking.
It says in the problem, use the conservation of energy. So if you're noticing the trend, we're using conservation of energy on all 3 problems for energy. But it'll tell you. That's all right. Anyway, golf ball is driven from the tee with an initial speed of 52 meters per second. Use the conservation of energy to calculate the kinetic energy of the ball when it reaches a height of 24.6. Go through that again. They're trying to get us to calculate, kinetic energy? But hey, there is no kinetic energy letter on here.
look, that's
You got the right idea. It's this one. So written on your equation sheet, you'll have this: EK equals 1/2 mb squared. That indicates that this term is kinetic energy. So we're going to replace this with one letter. And for those that asked before, this is the case where we can't cancel the m's. M is a part of kinetic energy. So if we're solving for it, we need m to be in there. So the long story short is, the thing to know is that if you are asked for energy or you're given energy, you can't cancel m's. Should I write that out?
So wait, is it
So the initial height would be 0.
Initial height would be 0 because it's on the tee. I mean, it's just a little bit off the ground. That's enough to call 0. Did you have another suggestion, Michaela?
I was asking if the EK does that even matter whether it's final or initial, or does it both?
It matters because it matters. Like they gave us, I think 52 was and they gave us a velocity of 52. So that means it's initial because it's at the
Okay.
beginning. Yeah.
Okay.
And I think final
So
height
let's
is
find the problem.
24.6.
So let's specify the problem, like,
Yeah, it's always, it doesn't really specify, but yeah, you have to figure it out, like which one happened first or last. I want to go green. .047 times 52 squared equals 0.047 times 9.8 times 24.6 plus EK final. Out of all the problems, this is probably the easiest math. What'd you say was on the left? 63 cool beans. 3. And this last step is just so satisfying because it's real easy. Subtract 11.3.
2.
Yay! 52.2. Unit? Joules. We made it. Yeah, I think so. Oh, did anyone die?
Oh, we're stuck.
Did you make it? So you've got 12 minutes to chill or to finish that. We will do the. What do we just end on? We'll do 13 and on Monday.